So the next person where you can gather even more knowledge from these four is Beliakov Aleksei. He's from Batman Moscow State Technical University from Russia. Give him a warm applause!
Hello everyone, my name is Aleksei Beliakov and I am from Russia. My research devoted to some generalization of Cauchy-Bunyakovsky inequality on set of the complex number and quaternions. So let's start my presentation with some words about me. Starting from this previously, I studied at the Lyceum number 1 of the city of Tuva in Russia. Starting from the 7th grade, I became actively interested in mathematics, solving different problems of increased level of complexity, more and more immersing myself into the subject. Starting from the 9th grade, I became actively participated in different mathematical competition, and in some of them, I achieved the status of a winner or prize winner. On the slide, you can see some of these math Olympiads. It is an all-Russian school children's competition. It is a Pokari, Vorobyov, Gory, and Lomonosov Olympiads by Moscow State University, and also it is Olympiad by Moscow Institute of Physics and Technology. Also on the slide, you can see my school, it is Lyceum number 1, and my classmates. So, continue. In the 10th grade, I took part in a math conference, and as a result, I became a diploma student. And also, my research was published in local university scientific journal. You can see it here. So, also from the 10th grade, I began to take part in some kind of math conference. It is all-Russian program of scientific years, Step into the Future. It's organized by my university, Bauman Moscow State Technical University, and I think it is prompted me to research activities. So, let's talk about my work. In preparation for participating in mathematical Olympiads, I first encountered an inequality known as Cauchy-Bunyakovsky-Schwarz inequality. And when I studied its classical algebraic proof, I noticed that it can be proved by using the next method. It is an algebraic method, it is a geometric method, it is using the algebraic and geometric means, using mathematical induction, and also using a convex function and Jensen inequality and Lagrange identity. You can see it on the slide also. So, some words about SIYSS inequality. SIYSS inequality can be considered not only on a set of a real number, but also on the set of a complex number. So, the inequality statement you can see on this slide. Using the definition of the complex number and write the SIYSS inequality separately from the real part and from the imaginary parts of the expression included in it, we come to the inequality known as we come to the inequality we come to the Cauchy-Bunyakovsky inequality, and it is a generalization. We come to the we come to the Maclaurin inequality, and it is named Maclaurin inequality. It is a generalization of Cauchy-Bunyakovsky inequality in case of two and tuples of numbers. So you can see this on the slide. Consideration of the inequality on the set of complex number prompted me to consider it on the set of quaternions. So what's it quaternions? Quaternions, which are a generalization of a complex number, are introduced by William Hamilton in 1843, and it is a hypercomplex number of a form A plus IB plus JC plus KD, where I, J, and K are imaginary units. So, by analogy with a complex number, the concept of the conjugate quaternions and norm of quaternions is introduced. On the slide, you can see conjugate quaternions and norm of quaternions. Also, you can see a multiplication table. And what is the norm of quaternions? Norm of quaternions, it is an analog for the model for complex number. So, here in writing down the Cauchy-Bunyakovsky inequality, and write it separately from the scalar and vector parts of its expression. After the sum transformation, we come to the inequality, which is a generalization of Maclaurin inequality to sets of to the case for 4n tuples of numbers. So, in conclusion, I want to say some words about this. The considered inequality is a finite generalization of Cauchy-Bunyakovsky inequality on the set of quaternions, and also it's allowed to use it with the 4n tuples of numbers, and the proved inequality can be used in space with a dimension more than 3. So it's allowed to use many classical inequalities and in analogous form. So thank you for your attention.
Beliakov, I can take this clicker as well. Thank you so much. How amazing wasn't Beliakov? Come over here and look at the audience, how much they send love to you. Yes. I have to ask a question here, like, I understand you have so much knowledge and passion into math and mathematics. If it's like someone who doesn't find it joy or find it, like, doesn't see it, like, what do you want to say to encourage these people? Like, is math fun? Like, how can we, what can we say?
I think the math, it is a great, it is a very great subject in your school, so you need to really interested in this. So, oh, sorry. I forgot.
That's good. More applause. Yeah, that's good. Yeah. That's a such good person over there. Yeah. It's people like him over here. You want to work with him because always a supporter. That's good. Yeah. No, but it's of course a big question I give you here now. But it's I just think like all the knowledge you have. But you think it's like interesting. It's good to use. Yeah, you say.
Yeah, that's true. But really, I want to ask you: can I make a selfie with all of you?
A selfie?
Oh, yeah.
Absolutely, absolutely. If you don't want to be, you can just hide. But let's take a selfie.
Come here.
It's good. You want me to be in it as well? Yeah.
Yeah.
Yay, nice.
Thank you, all of you. Thank you for your attention.
Beliakov. Thank you so much. That's good. We give you one more applaud, and you can.
Thank you.
Yeah, that's amazing.